Uh, right. We can wait for a few minutes and then start. Maybe I can just briefly introduce myself. I'm Gaurav. I'll be the I'll be taking the TS sessions for the programming in modern C++ NPTEL course. And the way we will go about doing this is I'll cover some of the topics that are covered in every lectures and maybe solve some questions or something. And if you guys have any doubts or something, you can ask in these tutorial sessions. So that's more or less about it. And it will happen, this classes will happen every Tuesday, 6 to 8. And you can think like this is going to be the case for like 12 weeks or so. Unless there is some changes in timings or something, you can check the forum, the website actually, the website of NPTEL for updates, and keep an eye on your emails also. I guess NPTEL should send you if there are any changes in anything or so on. So that is one,
So
and
that is one.
that and another thing is you can ask questions in these sessions. So feel free to ask if you have any questions. And another thing is, yeah, feel free to make use of the forum. So there is a Google forum for this course, and there you can ask questions which people can answer. Like um, there will be a lot more people answering that, so you'll have more eyes. So instead of waiting for every session every week, so this will be a weekly thing. You can, if you want to get your doubts cleared little faster, then you can definitely take advantage of the forum. So I definitely encourage to do that. And yeah, I think that's more or less it. Yeah, okay, right. I'll share my screen and we can get started, I guess.
Sure, sir.
Yeah, okay, awesome. I understand people will be from various backgrounds. So actually, this course is like it's technically a little advanced course. It assumes you know about C, like at least basics and some data structures and so on. But in any case, at least in TS sessions, I can cover some basic stuff that people are generally not familiar with, and then you can pick up other stuff as you go through the course. So yeah, all right, let's start now. I hope everybody can see my screen. So what I'll do is I'm using something called a terminal. Okay, so usually when we try to code something, so this is VS Code with a terminal. Um, I definitely encourage to use any other ID you guys might prefer. So you can use VS Code or any other code writer. And I'll mostly use terminal to compile and run the code. So this setup is usually what at least I am familiar with, and a lot of people also use it. So maybe we'll go this way. You can definitely write in everything inside the terminal itself. Use Vim or Emacs, write the code, edit it, and then run it itself all in the compiler, all the terminal. So yeah, okay, let's get started. So first of all, this course I'll mostly focus on C++ and corresponding functions and what things are and so on. So, okay, let's start. I'll maybe save this file as hello. So the very first program or the very basic program that everybody starts with is the hello world. So maybe let's write that program, and we can go step by step what each of the thing even means. Okay. So what we're interested in doing is like trying to get some output for the program. So we want our program to run. We'll write some code, we'll get our program to run, and we want the program to print hello world. That's it. I understand it might be basic for a lot of people, but just want to get everybody on the same page. I'm just starting this way. All right. So the first thing I do is include. So a hash include IO stream. So to do any thing in C++, we call certain functions. And now these functions are defined in some special header files. Okay. So IOStream is one such header file, or you can think of it like it has a bunch of functions already defined. Okay. And we are accessing them. We're accessing those functions using something called a header file. For our program to even know this header file, I'm using this line. So hash include, which includes this IOStream header file. Now, why specifically this one? Now, IOStream is used for input and output. Okay. If we want any input to certain, so let's say we run some program or some code, we want to give it some input, or we want something for it to print to screen, right? So essentially, you can think of it like if I run my code inside the terminal, I can pass the arguments to it, and yeah. Is there a question? Okay.
Sir, I think everyone should mute their microphone.
Okay, I can mute people or mute all. Okay, that's fine. You guys can feel free to stop me anytime. That's absolutely okay. All right, so let's move on. So first thing I do is include file. As I was saying, IOStream is used for input and output. So let's say I want to give some input to my program from the terminal. So essentially that's something what I'll use for IOStream. And output also is something IOStream has functions for that, and which we'll see now. Okay. And then, yeah, let me start the main thing. So what we'll do is int main. You can make it as a void also, but I like one reason to do this main function as an integer is you can have a return type. So return zero probably you can, it's something like standard. So return zero means the program exited without any errors or something, and it reached this part of the code. So that's just for convention. You can absolutely have void main. Here, if you see the main function that I have is does not take any arguments. And sorry. Yeah, okay. So this main function does not take any arguments, but ideally one can pass arguments to the main function also, which we can see later. So for now, what I'm doing is calling this function enclosed within this curly braces, and which has some kind of code. Okay, and integer is the data type of that function. Okay, if it's void, then there is no return data type. Okay, if it's integer, it expects a return, so return zero. Now, what's why this function main itself? So now one thing to remember is in every C++, you have to have a function called main. You can't do without it. You can have more functions which will be called like one function calling the other, and so on and so forth. But the first function that always gets called in C++ code is the main function. Okay, right. So that's more or less it. And then what we can do is just let's use the standard library. So in by default, if you use any compiler, so like GCC or Clang or anything, there is by default the STL library or the standard templatized library. It's already included. Okay, as in you can access that, and it still has lot of functions which are useful for most of the code. As in, you don't have to write a lot of the code from scratch to use these functions. So as we will see um, later on in the course also, one function as such, what we are using is, okay, I think it should monitor the chat too, just a second. Mm. Oh, okay. So, right, void, it give error. Um, you can't return zero. So thing is, you can have void main also. You can try it. I mean, honestly, that also, what I would say is depends on the compiler. So there are certain things which are supported by some compiler and some things which are not. Okay, zoom more. Okay, is that better? I think you can just. Okay, no. Yeah, exactly. So some compilers will give you error and some won't. Ideally, what I would suggest is use latest compilers. So GCC's 12 or above should be good enough for most of the things. And because we will use some modern features of C++, so a lot of these features have come up after C++11 standard. So C++11 or C++17, so on, and or C++14. So there's a new standard of C++ every 3 years. So you uh, I would suggest use GCC 9 or something, I guess. From there, C++11 standard C++11 features have been incorporated. But you can be safe and just use GCC 12 or something if you're using GCC. Similarly, there is, I'm sure for Clang is there. These are open source and free compilers. You can definitely use those. I don't know about the version from where C++11 support gets started, but you can look that up online. Yeah. C++11 is there's a question, while using void main, we won't use the return zero. Yes, you can just put return or not even put that line. Both are equivalent. You don't need to put return zero itself. Yeah, if you use void main. And yeah. So compilers, you have other options also. You have Microsoft's compiler. You have Intel compilers. You can definitely use those also. I just will be using GCC for most of for the rest of this tutorial sessions. That's what I said. Okay. Now, standard cout is one of those functions which is available inside IOStream, okay, which you can definitely use. Now, one such function, it essentially, you can think of it like it takes care of input and output. So here I want output, so I don't need to write the full library for this or something. So it's already taken care of. And we can go a bit more uh, depth, but let me just finish this line of code. So let me just write hello world. Okay, right. And I will end this line with standard endian. So what is yeah, yes, the recording will be available, and you guys are free to access. So the links for the recording and whatever code I write, so they will all be shared with you guys. Yes. So I'll showcase most of the time write codes, and they will be shared with you in a Drive link probably. And lectures will also be uploaded in YouTube. You can feel free to look them up later also. Um, yeah. Now another thing is, yes. So the first function that we see as is a standard cout. Okay. Now standard cout is the function that we'll use for. Okay, this is another question. Like there's some lab type platforms. Yeah, you can use online code editors also. So there's a question in the chat about online writing code online. There are various resources available, and you can use those resources just to write very short code. So because most of the code that you'll do in this course are very short and they don't require a lot of resources. So that obviously, absolutely, you can do that. You can use Colab also, or I don't know about Collab though. There are resources like Ripple, REPL. You can use those. And you can always Google online. Collab, I guess, is mostly Python, so we will focus on C++. Yeah. Why print output? We always use STD. Right. Yes. I'll come to the standard namespace here with a double colon. So after after printing this, I was going to go like each part of this code. But yes, that's a good question. I'll come to that. Why the standard? Right. Okay. Now, okay, that's awesome. I have written a code here with standard cout. Just for now, just think of it like cout is the function name, okay? And endl is another function which just ends the line and puts a new line essentially. Okay, so yeah, let's go ahead. Right. So what I will do is maybe run this one. Okay, so what I'm doing is G++, though, so that is the C++ compiler of inside the GCC library, the whole suite. So G++ with -o, okay, and out. So this is the output that after compilation will give me. And here, if you see, I'm using something called -standard equal to C++17. So sometimes if your compiler by default doesn't support, let's say, some features from 17 or any other standard, like from that time, you can enable them by passing this line. So standard C++17 or so on. So yeah, by default, whatever is supported by the compiler version you're currently using, you probably don't need to use this line. Okay, depends on the code. Here in this code, this is a very simple code. I really don't need to use this line because I'm just using standard cout, standard endl, and just including iostream. So this is not required. But just to show you guys, I'm calling this function, okay, with my file name hello.cpp, and then I'm running dot out by using /out. Okay, this and is just a this is a bash line essentially, where this is the compilation line, and after compilation, this is the execution. Okay, I just combined into a single line. That's all. Okay, awesome. So we see that we have successfully compiled the code and run it also. So the output is printed hello world. Okay. Right. I guess so far so good. Any questions? I can take them now. Then we'll go into depth into each part of the code. Like there was a question about what is this standard, right? Okay. All right. I think there's no question. So, okay, question. We have online class like this during the course. Yeah. So the online class is this class is more of a tutorial session. You'll have it every week on Tuesdays from 6 to 8. Yeah. Oh, I see. Replit is paid now. It used to be free back then, so I haven't used any online editors. You can probably look up something online. But what I would suggest is you can definitely install compilers in your laptop or PC or anything, and then it's just compile and run the code. Usually that will be okay because most of the code that you'll write in this course are very small and they don't require much heavy resources. So yeah, that's one suggestion. Right. Oh, there's a question about S3 is the class. Okay. Classes and objects and so on, like object-oriented programming, we'll cover them in subsequent part of the course. Uh, Error like bulb. Okay. So VS Code itself, okay. Maybe one by one I'll go. So standard is not a class, it's a namespace. So inside namespace, you can have classes. We'll cover class and objects more detail, but let's essentially understand what a namespace is. A namespace is like a you can think of it like something I give a name to, as in I'll have a collection of let's say functions. Okay, like here main is the function. Okay, um, I can have various functions inside that. Um, there's something called a name. Okay, I'll give it a name. So standard itself is okay, data structures I can't, I mean, this is not part of the course, but maybe sure, if we have time, I can cover them. So data structures like stack queues, decks, sure, if we have time, but ideally this is not a data structures course. Yes, STL, how do I put it? Some of the more important ones we'll also look at today. Like I'll cover some STLs like arrays and vectors for today. So those will be those are very much used a lot. So you can definitely learn from that. Yep. Coming to the VS Code, well, okay. So the error thing actually comes because VS Code, you have to actually install extensions. So you can use extensions here like, okay, here, yeah. I don't think I have it here installed. Yes. So the C++ extension pack from Microsoft, you can just install that, or not the full extension pack, maybe if you don't require all the thing it comes with. So the themes and all probably not required. Then the C++, this extension is more, I guess, useful. So you can install this, and usually what it does is it can give you editing intelligence and debugging features. The bulb thingy comes because C++ VS Code itself was not able to find the header file or something. So usually the ideal thing is that the include file like this one here is there somewhere present inside something called a path, which is think of it like a collection of directories, okay, which a code from anywhere can access. So if it recognizes IOStream is there in like in some path, okay, IOStream and many other header files, it will have access to them. Then it will definitely like include it inside your program to compile it. Okay. So when it's not able to find that file is when you see those errors. So there'll be videos, I'm guessing, in the NPTEL course on how to uh, compile and all. But today I'll just show like compilation. But what I'm saying, sorry, what I meant to say is you can look up online how to install GCC itself. You don't have it in your system, or any other compiler if you want to choose. G++ is what I mostly use, but you do not need to restrict yourself to G++, is what I'm saying. So like by default, maybe your whatever operating system you're using doesn't come with, let's say GCC or any other compiler you want to use. So you can look up online to install that, and then more or less the rest of the things are similar. You just have to, and obviously, and definitely make sure that the compiler itself is in the path so that you can access from anywhere, or give the full path to the compiler. Okay, and then compile codes and run. So give it a try, and you can definitely reach out in forum if you have questions from that, right? Okay. So if you see here, hello.cpp was my file. Out is an executable that was created. Okay. Now that executable is essentially has all the instructions what this program is doing. So this is written in English, as in this C++, but it has certain nomenclature, certain notations that we understand. So we have written a code like this, but computer understands it in more rudimentary level, like assembly and ones and zeros, essentially machine code. So compiler's job is to translate this thing into machine code essentially, and that's what this file is. It has the instructions to actually execute what we want. Okay. Now, coming to namespace. Okay, so before that, there are some questions. Yeah. Just like that. Code debugging itself is a challenge. Yes, I agree. So what helps is going step by step. So if you have large code, um, the best way to debug is using debuggers. So you can definitely use debuggers to actually figure out what's happening. Compilers are very useful, helpful, also and useful. They give you errors if you have compilation issues in your code. So I can probably do it, make some error like this, and okay. So if you see every line in C++ has to end with a semicolon. So let's say I don't do that. See, this throws an error. So it expects a semicolon after the end. Okay. So things like this are definitely useful when you're compiling. But when you're running things and getting errors, it might be a bit difficult to understand what is happening. Are you running into segfault kind of errors, or are you getting answers that you do not expect? Then it's useful to look at the code piece by piece. So here it's a small code, so you can look at that portion and try to understand what each function is doing. It comes from practice, and I definitely encourage to practice as much, because every topic that you don't understand, the more you write code and practice and change things around, the better you understand what it is actually doing. Okay. So another question, whether the line we use using namespace standard and standard is same. Yeah, so it's a question. It's a very good question. Um, so there's some, okay, so maybe you can combine with the namespace thing itself. What I'll do is I'll answer this question about using namespace. So let's say you do using, yeah, this you can go ahead and ask them. Yeah. There's a raised hand. You can ask in the chat, or can I'm still going through the chats. I think there are quite a lot of questions. Okay. So maybe I'll take the namespace one first. So using namespace. Okay. So there is this whole thing is there. Anyway, that's fine. I don't need the full thing. I'll just have namespace standard, right? Now, see, thing is, when you say using namespace standard, okay, then this is a valid code. Yes, I'm not denying it. You don't act. So using this, what happens is you actually don't need to write code the full like with standard. So you can just ignore um, giving the namespace. So namespace, think of it like I have certain functions inside some a given name. It's just some way of calling those functions. So the main reason to have different namespaces is if I have function called cout, it does some certain thing inside the STL library, standard library. I can have my own custom functions called cout, and they will do something else. It's absolutely valid. So to distinguish between those two functions, I can have my own custom function inside some other namespace. Okay, we'll see how to do that. So if I do using standard namespace, good work. Okay, great, it works. The reason to do a line like this is because you don't need to write standard everywhere whenever you want to call functions from standard. But this is actually not recommended because, I mean, you can definitely do it, but it's not usually recommended because giving namespace, right, actually tells you where that function actually comes from. Yes, it makes your code longer, but a more readable code is much useful and better and more maintainable than a code which is hard to debug or hard to understand, especially if you have functions which come from different namespaces and both are included. Let's say the header file includes my header file, which has cout, but in a different namespace. Then there will be collisions, and compiler will anyway throw error. it won't understand where it's coming from. So you have to actually give the full namespace anyway. So ideally, I mean, for small codes like this, you can definitely get away with using namespace standard and go through the whole code. That's okay. But ideally, writing in big codes or like production codes and so on, it's usually recommended to, is that in a way think you can think like it's best practice to use the full namespace. So I guess I hope that answers the question. Right. Right. So the question is to use GCC or G++. So actually speaking, GCC is the GNU compiler collection library, the compiler collection. It's the whole suite. G++ is the C++ compiler. So because we'll be focusing on C++ throughout the course, use G++ is what I would say. What is the difference between debug and compile? Okay, so mm, compilation is the process of converting this code. So whatever text I've written, like 10 lines here, okay, you can include this also 11th line. So all these 11 lines, converting them so that when into some kind of machine code, ones and zeros, end of the day, so that they are run inside the computer is the compilation step. Okay. Now debug is more of a programmer side of thing. Debugging is when your code is not doing what you intended to do. You intended it to do it, maybe compile and run something certain way, but let's say it's not doing it. So that process of figuring it out is basically debugging. So like I said here, if I remove this semicolon and run the full thing. So here there is an error in line 7, okay, of my code, which compiler pointed it out. So this whole process that I'm doing is debugging. You can use debuggers. There are software called debuggers. You can use them to figure out certain runtime errors. So this is the compilation time error, which is easy to figure out when compiler itself helps you out. So usually these are easier to figure out. When you have runtime errors, so like seg faults and all, so definitely use debuggers. Useful thing to do. Yeah. Okay. Question is
Am
about,
I audible, sir?
yeah, go ahead.
Regarding the debuggers,
Mhm.
so why we need especially some different software if we have like suppose we are getting the error during the compilation.
Yeah.
So in the same way, we will also be getting the error na, during the runtime.
Depends. So let's say you get run into seg faults. It just throws seg fault. As I mean, when I show for if we have time today, if I cover vectors and arrays, I'll show you guys how to when you can run into some kind of errors that I mean, if you know what you're writing, then well and good. I mean, definitely. But sometimes what happens is when you do some accesses that you're not supposed to do, it is hard to how do I put it? It's hard to sometimes figure out which part of the code is actually doing the, I mean, has the error. Because sometimes you have huge codes, a lot of files, and something's calling somewhere and so on, so on. So in those cases, at least from um, perspective of code, what I mean is perspective of seg faults, it's easier to use just debuggers if you can figure them out. Yeah.
Okay, so as far as I got it, like suppose we are getting this error, so it is clearly indicating that we are missing the semicolon. So, but
Right.
in those scenarios, the error we are the information we are getting it in our terminal that
Right.
will not exactly indicate
Right.
where exactly we did the problem.
Exactly. Exactly. And
Okay.
yeah, and if you just have simple arrays, they are not too difficult to debug. But sometimes, okay, we'll discuss, I mean, we'll learn about classes and constructors and destructors. So sometimes what the problem happens is your error is coming at a certain line. Let's say even your debugger will tell you the problem happens is that it will show you a certain line. The let's say at line 70 or something, the error is happening. The error is not happening because you there's actual error at that line. But because there's a destructor being called on some object which already doesn't exist. So there are various kinds of error that one encounters, and it all comes through just practice and getting used to things in coding.
Okay.
Yeah,
Like the error we are getting in the screen, that maybe then that may not be the root cause,
exactly, exactly.
but when it
Even
is.
yeah,
Mm,
even certain debuggers have hard time figuring that out sometimes. So that's
okay.
the it's
Mm,
not always straightforward, but we have tools, and it's always better to, I mean, I wouldn't say better. Some people like to put print statements each line and then figure out debug the very old-fashioned way. That's absolutely okay. I am myself guilty of doing it a lot of times. But what I would suggest is if you have tools and you have the time to learn and all, definitely go for it. It will probably save you a lot of time. But
oh,
yes, yeah, there are there are some like this one example I was giving. It's sometimes possible that debugger won't help you always, but nonetheless, it will help you for most of the cases. Yeah,
okay.
yeah. Awesome. Any other questions? Or else I can go to the chat. If there's, okay. So question is not about debugging, but about being able to have technical account, like you're saying the objects in a way communicating the code with systems. Yeah, right. Next is outfile automatically generated when we run the program, sir. And while running the program in VS Code, we should give path or directly we cannot. Yeah. So essentially, you can think of VS Code's terminal as, so actually, if you see this terminal, it's at, if I do PWD, so it's at this position. It's already inside the code where the hello CPP is there. The out is already created. So I don't need to give the full path of this dot slash out. I mean, like this, essentially, I'm running the code as an executable. It's an executable, right? Uh, no, yeah, better. So this dot slash out is essentially I'm executing the code. This, you can think of it like this is the way you execute the code. Now, because I'm already inside the path, I mean, I'm here in this directory, I'm creating the full executable and everything from hello.cpp. So I can just do it this way, and out will give me the actual output. So yeah, you can give the full path of out, yes, but it's not really required. Okay. I mean, if you are compiling in that line and so on. Okay. Next question. Yeah, what topics? So topics will mostly be very basic topics like I'll cover, like I already covered writing a basic code. I'll cover namespace, I'll cover arrays, I'll cover pointers, I'll cover vectors. Uh, it's okay if we, not all topics are even covered because mostly the session is aimed towards clearing our doubts. So feel free to ask. That's absolutely okay. But yeah, this is more or less what I plan to do today. Uh, Where to go return value? Yes, that's a good question. So um, think of it like this. So a return is essentially end of any function. Okay. So the question asks about the return value of main function, where to go. So return itself ends the function. So here my function is main. Now this return zero is the end code, like zero output for the program itself. Okay. And there are ways to deal with error codes where you can capture what your program returned. So zero, I won't show it here today, but and anyway, it's not always required in most cases. But just to have an idea, you can think of it like after I run my dots out code, this executable, I can sort of capture the result it returned. Okay, so that will be, it's mostly for error handling. So the return zero is essentially does that. So the code zero is your program saying, yes, I returned you zero and do something with it. So you can have like, oh, if it returns zero, I'll do something else after this code. Or if it returns one, then something else, and so on and so forth. Okay. And what is meant to explain class object and member function? Yes, of course. So there are concepts about class, objects, member function, and so on. We will definitely cover them in subsequent classes, but not today. Yes. Yeah, I think that question has been repeated. Okay, so main function return statement indicates successful execution program. Um, in a way, yes, you can think of it that for now, because in my main function, I only have a useful function is this line of code, piece of code. So after this gets executed, the next line that should get executed is a return zero. So one can think that a successful return of zero by main is successfully completed. So my program is done. Yep. Okay, I'll maybe comment this line. Actually, it's better. Yep.
And sir, it also works now when we don't put that exit status thing return zero. By
Yeah.
default, it takes the thing.
Yes.
Internally, it takes that.
Yes. Yes. Absolutely. This is if you have integer main, so the default is zero actually. Yes. This is not usually required. It's just you can think like I'm just putting it for um, completion. Yeah.
So
But
it
it's
is
not.
going as like readability mode readable.
Yeah. You can remove it. That's okay. That's
Hmm.
absolutely. Um, Okay, so for now, just to keep the code, what I'm doing is just keeping it commented if you want, because I'll be sharing this code mostly. So I want some of the code to be there when you guys look at it. Yeah. So right, let's do namespace. What I'll do is, I wrote this line, right? I want a function now. I mean, there's a main, sure, which calls this hello world, but right now I want to write it this way. So I'll create a hello function, okay, and have the code of hello world inside this hello, okay, and call that function itself. So here I'm doing a very basic thing, but this is very important to understand in C++ and in general C also. Okay, in general, a lot of programming, we don't have all the code. Like for now, this is a small code, yes, but think of it like I want to do a lot of instructions, so like a lot of code. I won't put everything inside main. I will put it lot of sometimes inside some function and call that repeatedly. Okay, so that's the idea, to have repeatability, to make the code more readable, so on. So we use something called a function. So here main was a function. Here I have defined something called a hello. Okay, and it's a void type because there is no return, no need also for the return, and just call that function and with semicolon. That's it. Okay, so let's run this guy now. Awesome. So you can see that I've got this hello world done. Okay, nice. So this function is called once here. You can write a loop. Okay, so two important things about you will definitely use a lot of times is a if statement and a for loop. So get familiar with them. So a for loop goes something like this, where let's say 10 I plus plus. Okay, so a for loop has an initial uh, declaration. So like here I declare I, which is an integer. You have to declare the data type always in C++. So, well, most of the cases now in modern C++, but think of it like you have to always have data types. That is for sure. You have to have declarations specifically integer. I'm declaring it as integer I with setting it to be 0 initially. Yeah, so the question is session for basics. Yes, I'll start with the basics, give you some idea about STL and so on. And if you have any questions regarding this, I can just cover those. Next class onwards, I'll cover more other topics that as the course progresses. So yeah. This is one statement of the code. Then you have another part of the code, which is I less than 10. So that is like how many times, like essentially where I want to terminate my for loop. Okay. And I plus plus is the increment. So it's like I is equal to I plus 1, essentially a shorthand notation of that same code, where it says every loop I will increment my I or change my I in certain way. So that is the third part of the code of the loop, right? And just run hello. Okay. So yeah, here it's just a format document which indents the code. That's all I'm doing here to make it look nice. Okay, good. Let's run this code. It should print 10 times. It did, as we see. So essentially, that's a loop. You should be familiar with this. And
Oh,
then
along with hello world, could you print I also?
yeah, sure. So let's say I print number 5. Okay. Awesome. So the more code I have, I can just put it inside a function and then keep printing it. You can
So I
combine
mean,
it also. Hmm?
so
Sorry.
I mean to say that I which we are having in the for loop.
Okay, okay, okay. Good. Okay. So you meant the variable I itself. Sure, let's do that. So now if you see, if I want to print, let's say, the number I, okay, as in whatever the value I has. So I'll do it this way, but do not forget to include inside parenthesis now, because if you have just a single line ending, you do not need to put parenthesis, but now you have to, because we want the both the lines included for the for loop. Okay, simple mistakes, but just something to be careful of. Yeah, assignments are handled by other TAs. So usually I mean, I'm just from PMRF side where I'm doing this TA-ship. Questions are set by them, and related to assignments, if you have any doubts or anything, you can definitely post in the forum. Yeah, I won't be solving the assignments, but doubt clearing is mostly what I do, as in from concepts and all. I won't be solving assignments. Okay, right.
So I wanted to know one thing. Sometime we also encounter that plus I, that thing. So
Yes,
will it
yes, yeah,
create a difference like in this program if you are going with I plus plus and plus I?
right. So what's the difference, right? Yeah. So essentially, if you take any modern compiler, the if you can actually go to there's an online resource called I think Godbolt. It's essentially it disassembles the compiler. It basically shows you the assembly code of that. So if you see a compilation line for this guy, it will essentially be the same. Any modern compiler will see that what you're doing is you have a for loop, you're incrementing I. There is a difference between I plus plus and plus plus I, but in the context of this for loop, they're exactly the same. So it will generate the exact same assembly code. Your code will be running the same. It will perform the same. Everything exactly the same. But now what's the difference? So if I have plus plus I, okay, and let's say, okay, maybe I'll just put it outside. Let's say I define something called J, okay, 0. And I have J plus plus n. Okay. Now if I try to print J, what do you think will happen?
It will increment by one.
Yes. So the output of J that we expect here is 1, right? So since J started at 0, J plus plus is 1. So let's see that. Maybe I can mm, comment this one out. It's not really required. Okay. So J is 1. Now let's say instead of J plus plus, I do plus plus J. This is just to showcase as a starting point. I'm sure you understand the output will be the same. It will be same, yes. But what if I do it this way? Integer a equals to this, integer b equals to this. Okay. Now I will print a and b both. What do you guys think will happen? Okay, there's an answer in chat. Let's see. So yeah, in general, looking at code, you can think how certain thing performs or you expect it to perform. Uh, you can always confirm your thinking just by running the code. Okay, so it's a always a good check. So that's the what I would say. Um, yeah. So why this has happened? Yeah. Okay. I'm sure a lot of people got it now. Okay, it's okay. So I'll explain each line by line. So initially, J was set to 0. Okay, so that is fine. J is 0 now. In this line, J is set to 1. Okay, so that is the J plus plus is the increment operator. But here the important thing is the return type. So actually, if you see, this is in itself is also a kind of a function, J equal to J plus 1, yes, but what it returns, that is the important thing. So here it returns the value of J before the increment. So the value of J before the increment J plus plus was 0. So it will return that here. Plus plus J returns the incremented value. Okay, so here J was 1, it gets incremented, goes to 2, returns 2 here. Okay, I hope you get the difference. So if I don't have this line, uh, I mean, how do I put it? Okay, so let me comment it this way. I'll set it to 0. I mean, it doesn't make any sense, but because I explicitly set B to 0, it is 0. That is okay. But the point here is that J++ has a return type itself. So every function in a way has a return type. Either it's void, so void has null return type, no return type, or it has a certain integer or something. Yes, you can do minus JJ also. Yes, you can just play around with this. So essentially what I'm trying to say is J++ returns the value of J before the increment. So which is 0. So A has 0. Now plus plus J returns the value after the increment. So plus plus J will increment 0 to 1. Okay. I mean, here it was already incremented to 2. You have to be careful here. I'll just comment this. No? Yeah. So here J's value is 0. So it gets incremented to 1 and 1 is returned and stored to B. Let's check that. Oh, yeah. Not declared. So yeah. Compile will always be there for you. So as you can see, 1 is returned to B. Okay. Since now J is also set to 1, J will print 1 and B you'll get as 1 because that is a return type of plus plus J. You can play around with minus minus J, J minus minus also and see the same results. Yes. Yeah, in void type, why return 0 is not there? Yes. So when you say return 0, you're returning something. So 0 is the integer there and void type has no data type. So as such, you don't need to return 0, but if you still want to return something, you can just return, sorry, you can still return and end the line. This is valid also. By default, this is what happens in this function. So essentially, it's not required to return anything because it's a void function. But if you still want to, for the sake of completion or something, you can want to write, you can write this way. Why you write plus plus j? No, this is just I'm giving an example of plus plus j. What's plus plus j? What's j plus plus? Like, what's the difference between them? The question came.
So
Sorry.
regarding A and B, like we got that how the value is being returned and stored
Mhm.
in A and B.
Yeah.
That part is clear, but
Okay.
what about the part of the J itself? Like J is not going, is being impacted. Like J की value पहले 2
Yes.
थी and 1, it is being same. So how that's working for J itself?
Yeah, it does get impacted. So if I have these values, let's say I print now. So if you see J gets 2, it was initially 0, it got incremented twice. So J itself gets affected. And when here it's printed, so actually I can do one other thing. I'll print J here.
So it got incremented twice, but it is
Yeah.
not impacting that if it is post incrementing or pre incrementing.
Post and pre-increment still affects J. What happens, the difference between post and pre-increment is that the return type. So that only affects A and B.
Okay.
So, so if I print this line now, so you'll see J after the first line, it is zero, as expected. We did not do anything, we just set it to zero. Now it is set to zero, and that's what we're printing. Then the next line is A is J plus plus. So here the increment happens on J, and we see it print one. Okay. And now, but because it's the plus plus operator, like J plus plus, the post operator, the return type is previous value. Okay. So that's what A prints, which is zero. Now, A is not get affected, does not get affected anywhere else. So whatever A gets printed here is the value, whatever happens here itself. The next one is J plus plus J, where J again gets incremented. Okay. And the incremented value gets stored in B. So finally, you see B is the same value as J in this line, the last line. Okay. So I highly recommend writing code. So the best way to understand code is just write and try to put print statements, try to understand, make some changes and see, okay, why does it behave this? And then you can actually think more about it. So yeah.
Okay, so the difference was in from the returning things. That's why in the
Right.
loop we were having J plus plus or plus plus J, that was not creating any difference.
Exactly, exactly. So
Hmm.
because in a for loop, it doesn't really matter what is the return time here because we don't
Return time.
store it or do anything with it. That's
Hmm.
the thing. Yeah.
But when we are doing anything with that variable, then we have to take care of that.
Yes. So
Hmm.
here the good thing is anyway the increment operator plus plus I or I plus plus will increment only I. But if you store it in something, then you have to be worried
Hmm.
like here. That's
Yes.
it. Yeah.
Hmm. Okay.
Yeah. Okay, good. That's good questions. Oh, sure. I'll explain the output. There is unsigned type and value of the variable is also zero while what is happening performing operator on the variable. Yeah. So there's something called typecasting, which we will cover in some lectures down the line. But essentially, you can think of it like unsigned int is still zero. I mean, the minimum value it can store is zero. So zero is okay. You can put unsigned int here or not. I mean, both are equivalent for now. You can think that way. But they're both integers. The difference is that unsigned int only goes from zero to some positive number. Integers can take negative numbers also. I'll explain the output again. So what's happening is, first of all, we'll comment this and then run. So I'll just repeat this. I declare j as an integer equals to 0. Okay. And then and then I'm just printing j. So that is what I'm getting is just 0, right? Then the next thing is the j plus plus operator, the increment operator. So there are two kinds. So the pre-increment and the post-increment. So in the post-increment, the uh, j's value gets changed. Actually, technically, in both the cases, j plus plus and plus plus j, both of them get changed. Okay. But the main difference is that it's on the return type. So this plus plus j is, you can think of like actually a function like hello or some other name. Okay. With some value, it is actually returning. Usually in a loop like this, there is no return. The return doesn't matter because we don't really use the return itself. We just increment it. So j here gets incremented, goes to 1 is what is printed. But whatever is returned by j plus plus is what is stored in A, right? And if we print A, we see it is 0, which means the value that is returned is actually the previous value before increment. So remember, j plus plus returns the value before increment, plus plus j returns the value after the increment. Okay. And if you ever have any doubts or questions, you can always write the code and just see the output. That's the best way to confirm it. Ah, question 923. Okay. Should be 0, right? As you're not printing A there. Huh. I'm not printing A there, yes, but if you see, A is only changed. I mean, if I have this code, I'll go back. Uh, if I have, if you see this portion of the code, the only I'm actually changing A or getting A is getting affected is only this line. I can actually print it later or here, it will still be the same. I can print the code and show you. So A is 0. So in all the outputs, A is 0. So this is the first time I'm printing A after it gets incremented. A is 0, and I'm printing it again here. It is still 0 because I'm not changing A. It was already set when in line 22 where J++ returned it something. So it just happened that J++ returned 0. So that's what was set. Okay. Hope this makes it clear. Awesome. Okay. So shall we move on then? J++ and J++ both same. Yeah, that should be okay. Usually you can use this small brackets to tell the compiler that I want this operation to be done first. So for example, integer a equals to, let's say, 5 minus 3, oh, my bad, minus 3, and then multiplied with 3, let's say. You can, it's essentially like normal how we do maths in pen and paper. These small bracket operators are meant to do some operations first and then move on to some other operation. Here I've given an example of a arithmetic operation. You can have operations like this also. Okay, I guess this is a good time as any to introduce the ternary operator. So let's say uh, there is an expression like 5 greater than 10. Then this will be set to 6. Okay, I can maybe write it this way. Yeah. Now, this code, what does it even mean? Okay, so let's go step by step. Here I'm saying it is an integer b, okay, which is equal to, it is set to something. Okay, so now this whole thing is something. The first part inside the bracket is 5 greater than 10. So this is a boolean. This is a comparison. A 5 being greater than 10 will either return 0 or 1. Okay, here in this case it is false, so it will return 0. That we know that, but this is a conditional statement. Okay, and this is called a ternary operator. So a ternary operator evaluates the conditional and then sets, and then there is a return either 6 or 7. So the true clause, if it's true, as in this part is the true clause, if it the statement it evaluates is true, it returns 6, else it returns 7. And yeah, correct. As in chat, one has already pointed out, the return will be 7. So if you print B here, the return will be 7. So here again, I've given a very simple arithmetic, but you can actually have function like func, let's say. So depending on the return type of the function, okay, so you can put brackets, evaluate that, and then function, let's say func, and then mm, I put -7 or -6 or something. So whatever my function has returned, if I subtract 6 from it, okay, here you might think that this will be an integer. Even integers have also some sort of way of thinking if they are Boolean or not. So usually it is if it's returns 0, then the Boolean part become you can think that the Boolean is saying the return is 0. Else more or less for every other integer it is 1. You can have like, let's say, equal to. So if the which function itself returns 6, let's say, if I imagine it's some function which is returning some integer. If it returns 6, then I want this to happen, else this to happen, like that. So the bracket itself, you can think of it goes beyond just arithmetic. It is used in many places, but to essentially the point here I'm saying is brackets are used to evaluate in order. So first this will happen and then so on, so and so forth. You can have brackets here also like this. And okay, this, and then you can just go crazy, like have something like this. Yeah. Okay. Okay, moving on. We don't have any value. Oh no, that's the here I've made an assumption that there will be some return type for function like integer or unsigned integer, something. Yeah. And return the function is just for an example, I'm just showcasing. Yeah. Okay. Right. Just a thing I want to say, if you guys are going to ask something, then unmute yourself. Otherwise, don't unmute because it disturbs the whole class. Right? Okay. So let's move on. Okay. Now let's discuss something about namespaces. Let's have the for loop for now. Okay. That prints something at least. Now, we already saw the namespace standard. So standard is what we are seeing now. But let's write some custom namespace. Okay. So I'll write namespace. Okay. And give this namespace the name as my namespace. Okay. Values. Yeah, that's fine. Now, inside this, what do you call namespace? I'll put this function. Okay. So if you see, yeah. Now, I've declared something called a my namespace. The namespace that I have declared is, or maybe I'll just write it as custom namespace. Maybe easier to understand. So this custom namespace, yeah, this I think comment which it made is incorrect now. Since I changed it, you probably made the correct one now. Oh, there's a question about when we use equal to and equal to. So very important question. So when I say integer a equals to 0, then I'm setting the value of a to be 0. But if I write equals to 0 or 1, here again I'm setting, but b equals to 5, let's say greater than 7. No. Yeah, let me be, yeah. So the main difference is that equal to is a comparison. Yeah, somebody else already answered. So equal to is to check. Yes. More specifically, it's a comparison operator where we are comparing two things. Usually it is comparing values and such. So if 5 is equal to 7, which is not true, we know that, but just to compare two values on left and right hand side, we use double equal to, which compares the value and returns a Boolean type. It's very important to know this is a comparison operator. It will always return a Boolean, which is like you can think of like true or false or 1 and 0. Okay, in that sense. So hence I'm storing it inside a bool, assigning it to B, is hence I'm using equal to operator. Okay. Now, yeah. So what I did is I made a namespace. Okay, we are probably, and that's fine. I made a custom namespace, named it as custom namespace. Yeah. So inside this namespace, I've defined this function hello. Previously, it was inside. You can think of like a global scope, where integer main is in some scope, and hello was also in the same scope. Now I've defined this custom namespace. Okay, And now in this namespace will be my function hello. So I can't just call hello. I have to give the actual full namespace and double colon. Yeah, what's the namespace? So like I was saying initially, a namespace is essentially trying to separate a collection of functions. I had a function void hello. Outside this namespace, something looking like this, which is similar to the main function. Main function is not in any namespace, but you can have a function without any namespace, okay? Without any name or anything. You can think of it like um, this function, standard cout. This cout itself, actually what I can do is call this cout. Now what's happening is, instead of calling cout from standard library, I'm calling a cout function from my own namespace. Okay. Now, to avoid the collision between cout like bracket, so this is a valid function, but a call like this will not be recognized by the compiler. It'll get confused which cout are you talking about, because already my header file iostream has a standard cout, and you have also defined something called a void cout inside the custom namespace. So giving this namespace part with separated by double colon becomes very important. Okay, that's the importance about yeah, it's actually like creating your own library. Absolutely. Collection of functions that you want to keep it aside and give them a certain name. Okay. And the good thing is that function names itself, because they have to be sort of unique, they can't be like a collision. You have to have different namespaces. It's like a logical group. Yes, exactly. Okay, let's compile and hopefully there's no error. Yeah, correct. So I printed the out is what my function I've written the hello world, and that got printed 10 times. Okay, maybe I'll just do this. Okay, got printed 10 times, and also the I also got printed. Now I hope you understand the difference here. The standard cout is the function from standard templatized library, but the function cout is inside namespace custom CS.
Excuse me, sir. Can you repeat it again?
Oh, sure. Okay. So the difference here is that there is a cout function inside the standard namespace, which comes from the standard templatized library. That is the default library that is available to us to use. Okay. So that has one function called standard cout. What I did here is I created a my own function named cout exactly the same. Okay. But it just prints hello world with some return type void for void also. Sure, why not? But this cout is in my own custom creation. To avoid collision with standard namespace, I've given it in my own namespace. Okay. And similarly, I can have more functions. So let's say void add, which takes integer a, integer b. Uh, let's not call it void. I want it to return something. Uh, then I return a plus b. The only thing this function does is it takes a and b, it returns a plus b. Now, to call this function add, let's say, actually, this is a good exercise. Let's comment this whole thing and just call add. What do you guys think will happen? Any guesses? I'll just put the code. Yeah. You can think like all the rest of the code is just commented, so no need to worry. Then, yeah, let's try to see. Throws an error. Why? Can anybody say why do we see an error? How to save file? You just control S. Usually is that saves the file. Oh, another thing I would like to add from terminal, you can, yes, you have to resolve the namespace. I mean, it gives you a hint. So the compiler itself gives you a hint that there's an unidentified add, like it doesn't recognize it. The reason for that is it's actually inside a namespace. So you have to actually give the full name to actually call this function. Now, here also, what do you guys think will happen if I try to run the program? Yeah, yes, there should be an error. The reason for that is this function expects two inputs, A and B. So we have to actually give some input. Okay, error, right? What happens there? Let's say I fix this also next. Okay, let's see the output. It runs perfectly fine. Now, important thing here is we're not giving input, neither catching the return value. Yes. So here an important thing to note is I fix the error by giving it some input. Yes, but there is a return type. I'm not catching it and storing it, let's say, in some integer a or equal to b. This is actually valid. I mean, if you think about it, it will call the function, it will do all this stuff, but because it's not stored, asked to store into anything, it doesn't store it. That's all. If we, then how does it print hello world? Hello world, it doesn't, right? I don't call hello, so it doesn't print.
Sir, what is the difference between class and namespace, sir?
Yeah.
Normally, we
So
will create class, no? What is the difference
right.
between class and namespace? Yeah, thank you, sir.
Yeah, that's right. Yeah. So actually, you can think like because okay, this is a namespace where I've created a function. Okay. So it's like a collection of functions I'm storing inside a namespace. I can actually store a class inside a namespace. So I can declare like class, maybe a name like circle, let's say. I can declare a class and then store its objects, members, and all those things. So a class is think of it like I want a certain how do I put it? So let's say a circle. I can have a lot of circles, as in if I think of a coordinate system. So how is it defined? If I define a center, okay. So inside the circle, I can have a center variable which is store the center. Okay, let's say x, y, z, whatever coordinates. Then a radius. Okay, so these two values uniquely define something, an abstract idea called circle. Okay, so this abstract idea is called a class. All my abstract ideas, along with some randomly defined functions, can be defined in something called a namespace. So that is what a difference. That's the main difference. So circle, so the class itself is a different thing. Functions are a different thing. But namespace is a way to access those class and those functions. Okay, I hope the distinction is a little more clearer now. We will see classes and objects later on in the course, but what I would like to mention is, yes.
So it's one small thing regarding.
Yeah.
You could first complete this part, the class part.
Sure, sure. So what I was saying is the namespace is used to access a collection that you have defined for yourself. It could be classes, it could be functions, and it could be some other things also. You can have structs also inside. But essentially, the idea is that a namespace is just a way to segregate whatever things you're defining. Okay. Yeah. Question?
Yes, sir.
Thank you, sir. Thank you.
Regarding that see out, sir. So basically, we could see a function that if we go to the syntax, so we created the see out and we had that parenthesis that is defining our function.
Yeah, this one. Yeah.
So the one we created is the function. What is that one which is by default one? It don't have parenthesis. See out. What is that one? That is from the standard level, standard name.
Yeah, yeah. So actually, from that perspective, if you see this guy, ideally, you should always have the namespace. But let's say you do not um, give the standard namespace and say using namespace standard, then absolutely you can definitely like something like this line without any standard. This is absolutely valid. But here the cout, when you see, you'll see some code online or some other places which do not have a namespace, because for them the namespace is already been told as a using namespace standard. I probably had the code. Yeah, no. Here, I'll bring it up.
Yes, actually that namespace thing is clear, sir.
Mhm.
The part I was asking is that we created a function. Our
Yeah,
cout was a function.
yeah.
Uh, what should we call to that cout? It don't have parentheses. That what is this cout?
Uh,
Which is my standard name? Is it a kind of function? Is it
oh,
something
this
like?
one. Oh, yeah, yeah. Actually, oh,
Yes,
so
this one.
yes. Good question. Sorry. I think I get your point now. So normally when we write functions, okay. Yeah. Normally when we write functions, we give parenthesis, right? Here we are not giving a parenthesis. Yes, but this is also a function. Actually, this is a very how to put it? It's a different kind of function, because if you see here, I'm just calling that function with brackets and then just ending it with semicolon. Okay. But here it is, for now you can think like a function, but it takes inputs. Okay, what do I mean by that? It's actually taking input using this operator, double arrows. Okay, this string uh, enclosed within quotes. Okay, and again a redirect operator. Okay, it's like this double angle brackets. I'm giving it the variable I. Okay, and again the double angular brackets, and then I'm giving the standard NPTEL function again. This function I'm feeding into the other function. Now, this is what I was saying. So writing something like this is not straightforward. Okay, standard template library takes care of all that. But to understand what this means is, you can absolutely think of it like a function. There is no problem with that. The behavior of this function is slightly just different than this function, what we usually encounter. So slight tidbit here. So this operator, have you guys seen before? This is
In actually terminal
Shift
in the
operator.
dash.
yeah, in
In
terminal output stuff and so on. But what if I write it this way? Integer a is 2 plus plus and
Shift right operator.
okay. Now let's say I format, and that's fine. What do you think will be the output when I try to print a?
8.
Yes, that's a answer. Yes, 8 or 4. Oh, sorry, my bad. Something happened. Ah,
Left shift operator.
yes, the shift operator. Mm, and oh, okay. This is just my example. I should comment this thing now. Like that. Okay, great. Let's remove the for loop also for clarity. Okay. Now, yeah, the output is 8. Okay. So it is the left shift operator. Okay. Or left shift, yes. So we have the number 2, but you can use so now the number 2 itself, when it's represented in integer, okay, I mean it's an integer, but there is a way to represent this number 2 in the computer. Okay, so integer is, okay, by default 32 bits. So that it requires 32 bits to represent this number 2. Okay, now what left shift does is it shifts these bits, and you get a new number, and you get a new string of, so let's say 2 had certain way of looking. It had certain bits, so some of them will be 0, some of them will be 1 to represent this number 2. Okay. Now shift operator changes that order. Okay. Now when you read that 32-bit integer as a normal integer, the new number looks like 8. So this shift operation is done by this shift operator. Now, here's the thing about this function also. In a way, you can think like all these operations are also shift. It's not like shift, but it's a redirection of bits. So the bits that represent A, the bits that represent the string are all redirected towards this function cout. Slight tidbit, just so you know, it's not really required to know, but these are actually quite related. Now, this redirect operator is also overloaded. So when I say overloading, it is like having different data type to accept. So as in, so if I have um, like this function add, which takes integer a and b, what happens when I want to add integers like 2 floats or 2 unsigned ints or 2 so on. So all that taking, like, these are some more things we'll definitely cover later. Just I'm giving a brief idea about what these things mean even. So function overloading and all those things are already done for this standard cout function. Okay. So you don't have to worry what you're passing when trying to print something. Strings, integers, and all those default data types it covers. Okay. I hope the main takeaway from this part was the class, the namespace thing. I hope you understand. So namespace is essentially a collection of classes, functions, whatever it may be. Okay. If we call class name, then will it print corresponding predefined functions? So when you call class names, to access its functions, you have to create an instantiate an object and then call its functions. Let's say you want to access that function. We'll discuss classes and objects in detail later, but essentially that is the idea. How to use stack and vector? Yes, let's maybe give an example for that. Yes. I can maybe cover some other topics after that if time permits. Yeah, the code will be shared with you guys. Yes, including this recording of this lecture also, it will be shared. Once other thing, if you guys use terminal a lot, it's to familiarize with some commands. Like touch is a useful command to create a file. So I'll create uh, let's give example vector. So if you see, this creates a file called vector.cpp. Okay. Now I'll try to edit this code now. All these files will be shared with you. Yeah. Okay. So now, okay, great. As usual, I'll include the IO stream header file. Okay. Now the output is 8. For that, you have to understand how numbers are represented in. There's a standard by IEEE 754. Essentially, it is the representation of any number in a certain format. For integers, they use 32-bit representation. So you have to now understand how to represent a certain number in 32 bits or 64 bits and so on. Now it is, how do I put it? So because these are integers, there's a way to represent numbers. So like 1, 2, 3, 4, and so on. And there is a way to represent even decimal numbers. Okay, that will be 2.6 or let's say 5.5 or something. So each of them have their own rules of representing, be it 32 bits or 64 bits. I definitely encourage to look it up. But yeah, there's another answer. It's a binary representation of 2. If you shift 1 by bit by left, it becomes 010, which is 4 in decimal. Yes, that's correct. And if you shift it once more, so that's what happened here. I shifted it by 2. Yeah, that's correct. Shift one left and then shift one right. Yeah, yes, that's correct. Let me check this. Okay, great. So now we can move on to vectors. Okay. Now we saw that to print things, yeah. So the thing is, yeah, sorry. So to print stuff, I have to include IO streams, right? So when I say print, it is essentially accessing functions like cout and endl. You can absolutely call them functions. There is no problem with that. They just look a little different than these kind of functions which are usually used to. Okay. Now I want to access another class. Actually, vector is a class here, and you can even think like couts and standard endls that we sorry couts and standard endls also are sort of classes. Um, it's a might be a little confusing right now, but for now you can just think of them as functions. Okay, there's no problem with that. What we will now work with is a class, the vector class, and its included functions. So to access any of them, we use we do the vector. Okay, so we have to include vector. Now, yeah, that should be okay. Great. So usual, we'll have integer main, no input necessary. We'll have the default. Sorry, my bad. Default 0, just for completion's sake. And oh yeah, that's okay. The chat has helped giving the correct bitwise operation. So that's yes, absolutely correct. Now, this is some topics in programming are definitely useful to know if you want to go in depth. So for example, the representation of numbers for integers, for what is called the decimals, so like floating point operations and all. It is very useful if you know them. So I definitely encourage to know those things because we'll deal with integers, doubles, and so on. It gives you more perspective and more ideas, like actually what's happening. So yeah, that's something I definitely encourage to read up on. I understand not a lot of people have background in programming when they start with all these CS concepts, but if you want to understand little some things in a little more depth, it helps in learning those things. Okay, you can always pick up concepts as you go along. So this is something I would definitely encourage to read. And as someone has already pointed out, it's a very nice explanation on how bit shift operator works. Okay. Yeah, where we use vector, absolutely. So let's take some examples. Vector is something that you will use probably the most frequent because it's such a useful way to represent uh, certain ideas. So let's see some examples. Okay, so let me write integer. I'll define something called a size. Okay, let's say 15. Okay, then I'll define the standard vector now in the namespace vector. So the vector class, okay, is in the namespace standard. So we have IOStream. We had the again, this vector is from standard template library. It's inside the standard namespace. Okay. Now this is the vector class. Okay. We are accessing that function in a way, this data type. Okay. It's not a function, it's the data type. It's more of a custom data type because it's a class, but for now you can think of it like it's also similar to having integer. Okay. The whole thing we'll see now. And then I'll put integer as the template. And then let's say A and pass size to it. Okay, I've written a lot of stuff. What does it mean? So what this means is that I will declare a vector named A. The name of that vector is A. Okay. Its data type will be integer. Now, if you see single parent, like single angular brackets, it's a template. We'll cover templates later, but essentially you can for now just think that this A is a standard vector of integer data type. Okay. And the size of that vector is 15. Now, the obvious question, what does this size even mean? Okay. So here, I would encourage to actually brush up on some data structures concepts. So what is a vector? Vector is nothing but a list. Okay. A list is a data structure. Okay. It's an abstract idea where we, we have a collection of certain values. And very importantly, they are continuous. As in, so let's say I have, and I want to represent it inside a computer. So a very useful data structure that helps me to deal with list is a vector, the vector class. Okay, I'll repeat. There is an idea of a list. I'll explain what a list is. To represent that list and work on it, a useful data structure provided by standard template library is this vector class. Okay. Now what's a list? List is, it's like, and the useful thing about vector is it stores data continuously. So let's say at a certain position 0, I have some value. The next position, I'll store some other value. A collection of these things will be offset. So every offset will tell me where the other storage, other value is stored at predefined offsets. Now this offset is exactly determined by this template. Okay, we'll learn about templates, but think of it like it's integer since it is in general 32 bits. So every 32 bit will store a certain value. Okay, and I will then access, let's say the nth entry or the 10th entry, the 9th entry accordingly. Okay, so list is the data structure. Okay, and essentially representing list in a useful way of dealing with abstract idea of a list in code will be a vector. Okay. Now here the declaration of this function a, you can declare it just this way also. It is absolutely fine. Declaring it this way ensures that we create standard vector a, okay, with this size 15. So what I'm saying is I'm asking the computer, when the code runs, it will ask the operating system, hey, I want 15 integer storage allocated for my object. It will create it. Okay. Now, because I already defined how much storage is present inside this vector A, if I define it, then I will just work with those. If I require more, I can ask for more, or I can then resize this. So this dynamic resizing is the usefulness of dealing with vectors. And you can definitely, is vector same as array? No, they are not. So a so maybe I'll showcase example of standard array also. Let me okay, I can write that after this. So a standard array is different than a vector. So vector has memory, yes. It represents a list, yes. But the memory is from where? So this is another concept I definitely encourage you guys to read. If time permits, I can discuss this next class also a little more. So now the idea is behind vector is this memory is stored from RAM. Yes, but more abstractly, it's called a heap memory. So heap memory, you can think of it like a large storage or pool of memory where um, sorry, a heap is a large pool of memory where the you can ask for lot more data, and but the accesses from there are slower than something called a stack. usually heap memory are from RAM. So when you read data from, let's say, RAM to the CPUs, right? So it has to go through some interconnect, PCI Express or any other thing. Now, because of this data transfer, it is slower. But the good thing, the main advantage is that RAM is a lot more. It can be in gigabytes or terabytes. So you can actually ask for, depending on whichever system you're running, you can ask for much more larger numbers and sizes. Okay. Now coming to stack. So that was heap. Now coming to stack. Stack are usually inside the cache. It's the fast memory. It is smaller in size, but it's lot more faster than heap. And because it is actually physically stored inside cache, which is much closer to the CPUs, the CPU cores or the arithmetic units, the access to them is much faster. And a way to access this array standard array. So when we say arrays or standard arrays, those are stack allocated. And when we say vectors, those are heap allocated, usually on RAM. Again, there is a difference. I'll probably say limit yourself to thinking from heap and stack, because technically speaking, there is no limit. I mean, heap is usually also on RAM. It need not be, is what I'm saying. Okay. Question, yes. Okay. Okay, let's see example of this like vectors and arrays. Yeah. Yes, it will be uploaded. Yes, no worries. You'll get a link with all the recordings. Okay. Of yes, for a second. Oh yeah, you'll get a recording of all the lectures. So all the sessions that will happen, there'll be a YouTube playlist. You can access them. Yeah. I will upload these lectures, and the Google Drive link with all the code will also be shared with you guys. Yeah. Okay. So right. So let's see some more code to understand this. So what I do is standard key out. Okay. Let's say size. Okay. I want to actually just print the size of A, right? And A dot, there's a useful function inside this vector class, which is called the size function, which will give me the size of that vector. Since I already set it to 15 and resized it and declared, like set it while doing it, the obvious answer here, I think we all know it will be 15, but let's, for completeness, print it and see. Now, instead of hello, I'll compile vector and that should be it. Awesome. So the output is 15. Now, I think that is straightforward. So the idea behind use this even size is that I want to show you guys some of the functions which is available inside the vector class you should be familiar with. So size is one such function. It keeps track of the size of that vector. Sometimes you might think, oh, okay, why do I need to do that? Because you might be resizing that vector so many times. You in certain part of the code, let's say, you want to check what is the size of that vector. It helps in, I mean, definitely in debugging, but sometimes it's very useful in getting to maybe check something and do some other portion of code, or like, let's say you want to call some function if the size is something else. Like it can be various things, but this is one thing you should be definitely familiar with. Okay, so just give me a second. Okay, so size is one function. Then next is something called a resize. Now here's one major difference between arrays and vectors. You cannot resize arrays. They're fixed sizes because they're stack allocated. You can always um, deallocate, in a way, think of it. You can allocate some um, stack based array, like a collection of list. So list is the abstract idea of a data structure. You can represent in two ways. When I say vectors, it is heap allocated. When I say arrays, the same list is stack allocated. That's the main difference. Now, heap allocated lists, which are vectors, they can be resized. So let's say I resize it to 20. Okay. So, and now I'll try to print. The first one was 15. Now, because I resized my vector, now it is printing 20. Okay. The other thing, what one does is, let's say I write a loop. We'll see. So, okay, let's first write the loop. Let's then a dot size I plus plus. Okay, and then a is I. Okay, see out, and I will. So what I'm doing is, in a loop, I'm setting the vector. Yeah, I'll also print it. Why not? Yeah. So setting the vector, then printing it. Okay. Sorry. No. So this bracket operator essentially accesses each value. Okay. Where in this line 15, I'm setting it to I itself, each value. Okay. And here I'm just accessing it for the output. Okay. And yeah, that should be good. Okay, let's see. Let's print the output and see. So as you can see, the sizes were 15 and 20. Okay, and because the usefulness here is that if I give it just a dot size instead of 20, it will work even if I had given it some other number for sizes. So that's the useful thing about this line, like using the function size itself. I don't need to worry about the size of the vector. I can just pass the function here. As long as I is less than size, I will access the correct data and output also in both in input and output. And the good thing is, because you're accessing only the memory that you have asked for, like in this case or in this case. So this is very important. You're asking for memory in these two lines. While declaring also you can give the size. So there you're asking for memory. While resizing also you're asking for memory. Okay. So in these two cases, because you're actually asking for a certain memory, and with this line, you're within that limit, you won't run into segmentation faults. Okay. And because accessing values outside of the range you actually ask for is when you get segmentation faults. For example, if I do it this way, let's say +1, instead of ending where the size actually ends, if I go one step beyond, okay, let's see what happens. Oh, it did. Okay, so okay, I guess I can talk about another concept here. Uh, so what happened here is, when you ask for memory, usually, not always, but usually, the size that you get for that vector is not exactly 20. There is something called a capacity of vector. So I guess we can print that also. I think yeah, the word is capacity itself. So it will allocate. So capacity is the actual allocated memory. I mean, as in it has the allocation, but the size is something what you actually work with. Okay, for the class. Okay, this is the object actually, but anyway, for the vector A, the memory which is allocated is usually bigger than what you asked for. Okay, so it prints till 20. Yes, no, actually, because size is 20, but the 20th value, it prints to 20, yes, but yeah, so what I'm saying is the A which is the vector, the memory it is allocated by the program need not be always, I mean, it's usually more than that. That is the capacity of the program. Size is just the allocation that you're asking for that program, as in it is number of numbers it will store. Sometimes you might not run into seg faults like in these cases, but sometimes you might. Okay. As in, it might be overwriting some value. It's because I'm just printing it. It is okay because it's still probably in part of the program. Debugging cases like this becomes very hard. Okay, so let's print capacity and see. I hope it's yeah, see. So this is what I was pointing towards. The capacity of this A is actually 30. So let's try to print this plus 10. Okay. I hope we'll run into seg faults now. Oh, we did not. It's interesting because the capacity 30. Yeah, let's see. Let's push more. Oh, still went ahead. Anyway, ideally you'll plus 11. Yeah, ideally you will run into errors, but for some reason here in this program, because this program is
I
still
would print capacity
yeah.
again at the end.
Yeah. So this program is actually accessing memory, which is still this AI, let's say size is 20, so 120. We haven't allocated that much memory, but here we're trying to access a certain part of memory which we should not access. And so far we haven't run into any seg fault. So this is actually dangerous. We should not access these sizes, this portion of the code actually, like for this list, this vector. And as you can see, sometimes it doesn't throw error. It might throw error some other time. But the point of what I'm trying to make is here the code has certain memory. Okay, all these regions, there's a memory allocation for A, C outs, all the strings, integer function, like this integer main, everything. When we're trying to access some data, if it's part of the code, usually it doesn't throw up the might throw error if you try to write those memory locations. Yeah, we can try actually. I mean, actually not try, as in we are actually writing to those locations, but somehow they're not. Capacity 30, then how it prints 100. Yeah, that's what I'm trying to say. Sometimes this um, um, programs, when you try to access certain kind of memory, which is still part of the code, it is probably overwriting some region, which is hence it's not throwing you seg fault because it's still part of that program. Okay. When a program tries to access a certain memory outside beyond its own program, then OS usually throws seg faults or segmentation faults. Okay. Anyway, let's not write codes like this. Okay. There is another way of writing this loop, which is called range-based for loops. Again, this is a modern feature of C++, which we'll see down the line. What I would like to discuss and maybe end today's class is this. So one way of accessing writing data is what we saw is this this operator where I is there, and then we are using the bracket operator, right? The other way to write the same thing is this. What I'll do is I'll access the pointer of data, a dot data, okay? Then add I to it, okay? Dereference the guy, store I, and instead of accessing this, I will write it this way, a dot data plus I, okay? And then I'm dereferencing. I'll explain maybe this idea behind pointers in the next class, but the key takeaway here is that there is another function like size, like capacity, so on. There's a function called data, which gives you the pointer uh, to the first element where A is stored. Okay, there is I, which You can have shifts and so on and so forth. I'll explain what pointer arithmetic is, but essentially you can think like these two codes are equivalent. I'm accessing the ith element from that pointer and dereferencing to store the data. This star is essentially the dereference operator, and essentially these two codes do the same thing. Okay, I'll explain this in more detail, and this will actually make a segue for learning pointers. I'll explain the pointers, okay, in the next class first, and then come to this portion as to what does this mean? Okay. All right. I guess we can end. Yeah. So again, key takeaway on in today's class. The first thing is, of course, I have this lot of comments, but we saw what namespaces are. Okay, functions, right? Printing a simple hello world using standard couts. This is like sorry, this is a function defined STL library which allows me to do input and output, right? Again, some other function which takes some variables as parameters as inputs A and B. Okay. Then again, the hello world what we saw, but in a general setting, not inside a custom namespace. Okay, this also that's fine. If I using standard namespace, then I don't need to put standards, right? So this is one code. Shift operators. So there is one idea behind that as to how these operators are actually overloaded for all kinds of strings, integers, and so on. Then we saw like printing it in loops. That's then brackets. You can put brackets to evaluate them in sequences, and various kinds of code that you can then ternary operators. You can have comparisons. Then the post increment and pre increment operator. Okay, and here we saw some example of how to deal with a vector. I did not write the standard array code. I'll definitely do that also next class and explain about pointers. Okay. All right. I think we can end the class here and happy coding. Hope you guys enjoy C++. It's a fun language. Essentially, the idea is that coding you can do in a lot of languages, but C++ has its own way of doing things. So I hope you guys practice a lot to understand these concepts. And yeah, again, happy coding. Yes. Thank you. Thank you, everyone.
Thank you, sir. Good night.
Thank you,
Yeah.
sir.
Yeah. Good night.
You,
Thank
sir.
you, sir. Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.